All right, so I'm going to work through the homework assignment with you guys here. The first three are rewriting, so they're in radical form, and so we need to rewrite it using uh, rational exponents. So again, the rule is when you have the nth root of anything, okay, it equals x to the 1 over n. Okay, and so if there's a power on the x, you change colors here so it shows up better. Right, so if I have the nth root of x to the m, and then it's x to the m over n. Right, so the denominator is the index number, the numerator is the power. And so all we have to do is knowing that rule, rewrite these. Okay, so the square root of 7, the index number is 2. Remember, when there's no number there, the index is 2. The power on the 7 is a 1, so it's just 7 to the 1/2 power. All right. And then over here, the 9th root of 15. So 15 is the base, and it's to the 1/9 power. And then the cube root of x to the 5th. So now this one has a power. So it's going to be x, okay, to the 5/3. Okay, and again, 3, the index number is the denominator, the power is the numerator. So that's it. These are equivalent expressions. Again, this is useful, okay, because it helps us when we're multiplying radical expressions. If they have the same base, we can rewrite them using this and use properties of exponents to simplify. When you get to advanced math and calculus, all right, when you have rational exponents, you could take the derivatives and integrate these type of expressions. When they're in radical form, it's very challenging to do. All right, so now we need to actually evaluate. Okay, so it says without using a calculator. Yes, you could type these in your calculator and they'll tell you, but these are easy enough bases that we should be able to work with here. And so this is 16 to the 1/4 power. All right, and so if you need to rewrite it, you can. It's the 4th root of 16. You don't need to do this step. Okay, if you understand those are the same things, there's no reason to rewrite it. So we're just looking for, does any number go in, any number times itself 4 times go into 16? And so that happens to be 2, right? 2 times 2 times 2 times 2 is 16. Again, if you don't know that, the way you do this is you do the prime factor tree. So 16 is 4 times 4, right? Then 4 is 2 times 2. And so you can see that 2 shows up 4 times. And since we're doing the 4th root, we're looking for something that shows up 4 times. And since there's no singles or anything else, there's nothing inside. This is a perfect 4th root. The answer is just 2. All right, so this one says 16 to the negative 3/2. That negative is kind of hard to see there. All right, so this square root, right, the 2 on the bottom means square root. So the square root of 16 is 4. So we're looking at 4 to the negative 3rd. Right? What did negative exponents mean again? So we go back to our properties of exponents video from earlier. This unit, we know that means it's the 1 over. So this is 1 over 4 cubed. And then 4 cubed is just simply 4 times 4 times 4, which is 64. So 1 over 64. Again, we could have cubed it first, but 16 cubed is a large number. All right, and so it's usually easier as long as this is a perfect square or a perfect whatever the denominator is. It's easier to simplify the radical part first and do the power part second. All right, 4 to the 5/2. So in this case, right, we're going to go square root of 4 first. So square root of 4 is just 2. So it's 2 to the 5th. And so that is 32. So 2 times 2 times 2 times 2, I think I said it 5 times, is 32. Or we knew that 2 to the 4th was 16, so just one more is 30. All right, now, okay, number 7, 81 to the 3/4. So again, we want to do the 4th root of 81. All right, so that's 3. Again, if you didn't know that, you break it down 9 times 9. And now you can clearly see the 4 3s there. All right, so this is 3 to the third, right? And that's just 27. All right, now this is 64 to the negative 2/3. All right, and so since we already did 4 cubed is 64, so we know the cube root of 64 is 4. So this is 4 to the negative second. So that's 1 over 4 squared. So 1 over 16. All right, so again, some of these numbers you may not know at the top of your head, but if you look back, we did that table last week. You could use that table to help find these numbers, or again, just prime factor treat every time. All right, 125 to the 2/3 power. So cube root of 125 is just 5. All right, so this is 5 squared, which is just 25. All right, so these are nice, easy numbers. There's no variables in there yet. We're just simplifying. Again, you can rewrite them in radical form if that helps, because that's what we're used to doing. We want to get used to understanding that these rational exponents are equivalent. We don't need to rewrite. We know what it means. All right, as we advance through math, it's going to be easier to work with rational exponents than radical symbols. All right, we're going to keep going here. So we have 3 more with numbers. All right, and this is actually real important here, if there is parentheses or not on this. And so this negative 8 to the 4/3, this negative is not being raised to the power. Now, if there was parentheses around it, it would be. All right, but there's not. Okay, so it's 8 to the 4/3, and my answer is just going to be negative. All right, so cube root of 8 is 2, so I get negative 2 to the 4th. 2 to the 4th is 16, so it's negative 16. All right, so if the problem was negative 8 to the 4/3, then the answer would be positive 16. All right, because you'd get negative 2 to the 4th. And then because the negative is also being raised to the 4th, right? Negative times a negative makes it positive. All right, notice the difference, okay? So these are two, they look very similar, but they are clearly they are opposites of each other. All right, one's negative 16 and one's positive 16. All right, so let me go ahead and erase that off of there because that's not part of the question. You guys saw it. All right, number 11. So just like number 10, the negative is not in. Okay, if it was, then this would be imaginary because we can't square root a negative. All right, but it's going to be negative 6 to the 3rd. And then 6 times 6 is 36, times 6 is 216. The negative 216 is the answer. All right, and then this is just square root of 100, so that's 10. It's nice to run into an easy one once in a while. All right, so now, okay, these ones are going to be a little bit trickier, all these. I mean, 13 through 15 have variables, okay, and 16 through 18 don't, but even 16 through 18 are a little bit tricky. All right, so right here, we got to use our properties of exponents, right? We have the same base. When we're multiplying, we just add. This one's not too bad because I already have common denominators. So I just have to add 2/3 plus 4/3. So that's going to be x to the 6/3, which obviously we could just, 6/3 is just 2, right? So we're looking for x squared right here. And again, because it's the same base, we get add the exponents. If they are not the same base, we couldn't do this. We'd have to leave it. All right, you could only add those exponents together because the base is x for both of them. All right, so now in 14, we have a power to the power. So we're multiplying, okay? Our exponent's 4/3 times 3/2. So that is just going to be 2. Again, you could Go 4 times 3 is 12. 3 times 2 is 6. You could cross cancel, right? Any way you look at it, it's y squared. All right. Okay, now 15 is a good one. All right, so 12y to the 1/2 divided by 4y to the 1/3. Okay, so again, this 1/2 is only on the y. There's no parentheses around it. So that 12 is just 12. It's there. It's not being square rooted or anything. All right, it's 12 times the square root of y divided by 4 times the cube root of y. So with the 12 divided by 4, that's all you're doing. It's just 12 divided by 4, which is 3. All right, and then the y's, you're going to dividing the same base, so you're subtracting exponents, right? So you have this little side note over here, 1/2 minus 1/3. All right, and that's going to be my exponent. What is that equal? So we got to get common denominators. So 1/2 is 3/6. 1/3 is 2/6. So when you subtract that, you get 1/6. So it's 3 times y to the 1/6. Start that one. All right, so we got to make sure, like 13 was easy because it had a common denominator, so it's easy to add those fractions up. And 15, the denominators were not the same, so you had to get common denominators before you subtract. All right, 16, 3 to the negative second raised to 3/2. So again, this is power to the power. So when I multiply negative 2 times 3/2, I just get negative 3. So it's 3 to the negative third. Negative exponents means 1 over, right? So it's 1 over 3 cubed, and 3 cubed is 27. So 1 over 27. All right, now 17, okay, this one, it has a lot of common mistakes on it. Same with 18 for the same reason here. All right, so on 17, if you compare 17 and 15, right, ignore the 12 and 4 for a while. Right? We had y to the 1/2 divided by y cubed. The y didn't go away. The base stays the same. All you're doing is subtracting the exponents. Right? So what a lot of people do on 17 is they'll say this is 1 because 7 divided by 7 is 1. But again, that's not what we're doing. We're not doing 7 divided by 7. We're doing 7 to the 2/5 divided by 7 to the 1/5. All right, and so the bases are the same, which allows us just to subtract the exponents. So the base stays the same, and I just have to do 2/5 minus 1/5, which is 1/5. So nice, and it turns out to be a nice, easy problem. That's it, 7 to the 1/5 power. That's my answer. All right, and then on 18, same dilemma here. A lot of people want to go 6 times 6 is 36, and I want to put 36 in this. But just like in 13, right? It's x times x stays x. The base stays the same. We're worried about the exponents. All right, so let's combine these together before we worry about that power. So we're gonna get 2/3 plus 1/6. All right, so what is 2/3 plus 1/6? So you get 2/3 plus 1/6. So what do I need? I need a common denominator, which will be 6. So it's gonna be 4/6 plus 1/6, which is 5/6. Okay, so I get 6 to the 5/6, and all of that is raised to the 12th power. So now I just do power to the power, so I'm going to multiply 5/6 times 12. Right, 6 goes into 12 2 times. 2 times 5 is 10. This is 6 to the 10th power. Okay, and I'm going to leave that alone. That's a huge number. All right, you could type that into your calculator and leave that, but that's a very large number, so we're just going to leave it 6 to the 10th. All right, and so, parentheses are important. Where that negative sign is important. Okay, looking at the base, making sure the bases are the same, so we can follow the properties of exponent. All that stuff is very important.